Lesson 11.2 is our first of a couple different lessons where we will talk about probability. Today is more of, kind of the introduction lesson to probability. I think a lot of this you'll be familiar with because it's more of the basic probability, although we're going to look at several different things here along the way. And this first one, sorry, there's a hole punch here, but it is supposed to say experimental probability. And experimental probability, basic probability that you're used to working with probably. You've done probability back in middle school somewhere along the lines, maybe even elementary. You've done some of the basics. So, but for an example, probability of an event. So whatever you often see P, and then in parentheses there'll be the probability of whatever they're asking you to find. And then we're going to talk about a fraction. Number of times the event occurs over number of trials. So, number of times the event occurs over number of trials. So, how many times was delivered? On top, how many times that event occurs over total number possible of outcomes. Okay? So, let's look at the first example. Of the 60 vehicles in a teacher's parking lot today, 15 are pickup trucks. What is the experimental probability that a vehicle in the lot is a pickup truck? So basically, what is the probability that the vehicle in the lot is a pickup truck? You might, when you see this written in them asking it, you might see it as P of pickup truck, as in the probability of a pickup truck. What are your thoughts? She says 15 over 60. 60. Agree, disagree? No? Okay. So, on bottom, number of trials. Okay, total number of outcomes. How many total possibilities are we picking from? 60. Of those 60, how many times is it a pickup truck? 15. So the basic probability, 15 over 60. Now, I went through, again, because I haven't taught this chapter in a couple of years, so I was trying to brush up, make sure I was on the right path. I went home and through and did the homework this morning to make sure I knew what they were asking for. Because when you do probability, sometimes they want a fraction answer. Sometimes they want a decimal answer. Sometimes they want a percent answer. So I needed to kind of make sure I knew what they were looking for. A couple of them, they wanted fraction answers. A lot of them, they wanted decimal answers. I never saw them ask for a percent, though. Now, as a fraction answer, would this be acceptable? No, because why? It can reduce, yes? 15 and 60 technically both divide by 15, if you will, and you're going to end up with 1/4. 1/4 might be an acceptable answer. Or, what is 1/4 as a decimal? 0.25. How do I get that on my calculator, just for the record? 1 divided by 4. Huh? Or 15 divided by 60. Yes, valid answer there. Okay. Now, you have to watch your directions in homework. More of them want decimals than fractions. The decimals, sometimes they said 2 decimal places, sometimes they said 3 decimal places. So good luck paying attention to the directions, because it was a little bit of everywhere.
Wouldn't it always just be the smaller number divided by the bigger number? Because you can't have more events than the number of trials.
Yes. I hesitate to use the word always, because I'm trying to come up with some weird random exception in my mind.
Yeah, I'm trying to think, but I don't think of like any probability would go over 100%.
Right. And so, yes. Okay, so valid point most often. Usually. I can't use the word always here because there's going to be some random weird thing that, But yes, usually it's your bigger number on bottom, smaller number on top. Now, sometimes though you have to find your numbers. You know, they don't always just give you the two numbers. Maybe you have to add something together or subtract something. So you do have to read the problem. Don't just say, oh, number, smaller over bigger. That's not going to always work. But okay, let's look at the second example. A softball player got a hit in 20 of her last 50 times at bat. What is the experimental probability that she will get a hit at her next at bat? So we're trying to find what is the probability that her next at bat is a hit. So what are we doing here? How many hits are there possible? Based on past experience, 20 out of how many total options? 50. Does 20 over 50 reduce? Yeah, it's going to reduce to what?
2 over 5.
2 over 5. Math Excel might want that. Or 0.4.
That's a pretty good batting average.
0.4?
No.
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 Not 0.4.
But I feel like if you look at major leagues, it's a pretty good batting average. I mean, you're talking about professional.
I thought it was like 0.4, 0.5.
So.
Yeah, it's like.
Yeah.
It's.
Okay, so we got the idea here, right? This is just kind of review of basic probability. Now, simulation, okay? When we go down to example 2, we're going to talk about how to use a simulation to model an event. And we can do it in a couple of different ways. I will tell you, again, I looked at Math Excel to make sure I knew what I was, what you guys were going to expect. And they already have a simulation done for you. And so you'll just be able to gather data from there. We're going to do a simulation on this first problem here. So the example that we're looking, on a multiple choice test, each item has 4 choices, but only one choice is correct. What is the probability that you will pass the test by guessing at least 6 out of 10 answers correctly? Okay. Now, I'm going to use my graphing calculator to demonstrate a simulation, because the idea of a simulation is looking at a bunch of data. Okay, but if you don't have the data, simulating it. We could use dice to do this. We could grab, in this case, it'd have to be 4-sided dice, and roll 4-sided dice over and over and over to see what kind of options we're going to get here. Okay, now, I'm trying to think how I want to do this. In a simulation, you want to have not just 1 or 2 simulations. We want to go through this several times, and I think I'm going to go through it probably about 20 times. Okay, and each time what we're looking for, okay, each item has 4 choices. Normally, what do we think of those 4 choices being on the test? We normally think A, B, C, D, right? But instead of A, B, C, D, a simulation usually generates 1, 2, 3, 4. Okay, our calculator is going to generate a computerized, it's going to generate numbers. And so what we're going to do is we're going to say, okay, 1 choice is correct. And so by doing that, what I'm going to say is, okay, 1s are the correct answer. Okay, maybe it's an A here, maybe it's a B here, but, how many times is that happening? And we're going to go through this 20 times. So let me... Okay, so on my calculator, I have an option in my probability to do random, and I'm going to do random integers. And then, again, not that you guys are going to have to do this, but we have, my calculator's not Python, the newer ones are, but this one's not. We have 4 choices, right? So the lowest choice, I'm just going to set it up so it produces outcomes of 1, 2, 3, 4. So I'm going to set up my lower bound as 1, my upper bound as 4. How many questions on this test? 10. So I'm going to have it produce for me 10 sets of answers. And this will make more sense after I do it.
Will it be, unlike this one, would it be random?
You can do a random on that calculator.
There's rand and then there's rand like mine.
I don't remember, I haven't done it on this calculator.
I just went to probability and kept clicking over.
Maybe you can,
I think it probably is a rand.
but I'm not sure you can get 10 answers at once.
Yeah, you probably have to put it in different because it starts with the parentheses.
I know, and I'm trying to
So I don't
remember.
know how you would get the comma.
I know, that's what I was trying to look for. I'd have to look it up of how you could do this.
Yeah, there's a little comma.
There is a comma.
I don't see it.
Good job.
I found it.
You found the comma.
10. Oh, it says argument error.
Yeah, I don't know that we can get 10, but okay, so what I can do here, and this is, again, you're not going to have to do a simulation on your calculator, okay? But, so what I just did here is I did random from 1 to 4, and I asked for 10 results. So this is representative, what's up there, of one test, okay? And this is our, I'm going to say this is our simulation number 1. Now, on my simulation number 1, if we are saying that 1s represent the correct answer, okay? How many correct answers did I get by just guessing? I have 3 this time, right? There were 3 1s. Now, we're going to repeat that. We're going to do simulation number 2. Okay? So I'm just going to go up on my calculator. I'm going to repeat it. Now, this is simulation number 2. 1, 1, 3, 4, 3, 2, 1, 4, 1, 2. How many right answers did I get this time?
4.
I got 4 because there were 4 1s. You're seeing what's happening here, right? So we're going to go through this. I think I said 20 times is usually, we want to get accurate data here.
Don't have enough room.
That's 5.
Okay, I got 5 the next time, 5 correct answers. Yeah, I did 20 in my notes.
So you just need to take
Okay,
times.
so you guys are going to keep track for me so I don't have to keep going back and forth. 1, 2, 1. Maybe I should just write this down. I'm going to have to write it all down when I go up there, aren't I? Oof. Man, unlucky guessing there. None. How many here? 4. Can we see there? 4.
Is that sim 7?
Yes.
Can I use the restroom?
Emergency?
Yeah.
Yeah, sign out. We have 2. You guys are keeping good track of this, aren't you?
No.
I don't have time to write which simulation it is.
Okay. There's 3. Huh?
I'm on number 10.
Yeah, I just got the
Well, let me see. Was 4 1?
I'm on an 8.
4 was
Yes.
1, 5 was 2.
6 was 1, 7 was 0, 8 was 4, 9 was 4.
I got 9 was 3.
But I missed so many.
9 was 2.
Was 7 0?
7 was 0, 8 was 4, 9 was 2, 10 was 3.
I got 9 was 4.
I got 9 was 4.
Yeah, there were 2 4s in a row.
Yeah, so those lines were taken.
So that's 4 2. 10 was 2, and then 11 was 3.
Okay.
Wait,
Okay, sorry. I guess I probably quit saying some of them out loud, didn't I? I don't know.
Wait, so
Whereas
9.
You just kept going.
Chance that you
I did.
guess correct.
Because this one right here that I've highlighted has 4, and this one above it has 4.
How many are we So doing? where did I? Because then like.
You missed 11.
That you can guess correct.
So there's 4, then there was 2, then there was 3.
Oh, okay, that makes sense.
Why can't you take
Next one. There's 3. Next one has,
What?
okay, so 12 had 3. 13 that I just had did 2. Am I good?
Oh.
You're good.
I'm looking for ones, because ones represent my correct answer. With the simulation, you pick what represents the correct answer and just look for it repeatedly.
Did you get
Okay.
Just say it, right?
We have how many this time? 2. How many the next time?
What?
So the 14th time there were 2. The 15th time there were 5. Yes? Okay. Keep me straight. 1. 1 and 3 for the next 2. So those are the 16th times and 17th times. So what do I need? 3 more?
Yeah.
If I'm trying to get to 20?
6.
6.
You did it.
2. 6, 2, 5.
It's a 1 in 20th chance. Almost there.
You're guessing. That's the key.
It's a 5% chance. Maybe this chemistry.
This is like me just randomly going in and filling in bubbles. I mean, that's essentially what it's saying there.
That's what I do in Stanley's class. I don't think I've learned a single thing.
I thought you were saying my class at first. I was like, what?
No, in Stanley's he has like these scan things that I practice.
Okay.
I'm gonna set my bar I made a 2 on the exam.
Okay, guys. So, simulation. That was an example using a calculator. You could do this with dice. You could do this a lot of different ways, okay? If we just needed 2 answers, we could do this with flipping a coin. You know, there are different options. Now, we did 20 different trials here, okay? 20 different simulations. Those numbers there represent how many answers we got correct based on the fact that a 1 represented a correct answer, right? So that's how many 1s there were each time. Now, this first example says, what is the probability that you will pass the test by guessing 6 out of 10 answers correctly?
6 out of 10 is not passing.
So, probability of 6 out of 10. 6 out of 10 is 60%, thank you very much. And that is a D minus. So,
That's
passing.
That is passing.
Yeah.
it is not failing, it is passing. It allows you to play sports. It is not failing.
Exactly.
Okay, so, in my example here, guys, 6 out of 10. How many times did we get 6?
1.
Once. Out of how many total times did we try this?
1.
We tried it 20. And we could make this simulation bigger. We could keep going farther. But, you know, we got plenty there. What is 1/20th?
0.05.
0.05. So 1 over 20 or 0.05.
That's a good 5% chance. I'll take it.
Now, B. What is the probability of passing if a passing score is 50% or better? So what are we looking for here? If we're looking for the probability of passing, how many do we need this time? Last time we needed 6. What's going to be 50%?
6, 5.
5 or more, right? So this is going to be 5 or more. How many times did we get 5 or more?
1, 2, 3, 4.
Yeah.
That's a good.
4 times.
What's the probability of getting all 10?
Okay, Noah, focus. So what's the probability of passing here if 50% is passing? How many did we have that were 5 or above? 4 out of how many? 20. 4 out of 20, first of all, will reduce to 2 out of 10, which is 1/5. As a decimal, that is 0.2. Okay? So there you're up to a 20% chance. And that is based on guessing. Okay, that's the idea of a simulation, guys. As I said, you have one in homework that the answer is based on simulation. When I did it this morning, I just clicked on this little link and it brought up a chart of and it had a simulation of 20 answers. It was just zeros and ones. I forget what it was simulating, but it was the same idea, looking for the pieces here. Are we okay with this? Again, you don't have to actually do the simulation, so I think that was probably the confusing part right there, was doing the simulation and understanding what I wanted.
Like on a test, this one.
I won't have you do the simulation. I would provide the information
Would it,
somehow.
so would it kind of be like part B? If we did do it, we wouldn't have to do all the.
Maybe, or what you'd be given is you'd be given like, maybe I could give you the list of like what we were seeing up on the calculator screen, where you have to gather the data, but the simulation would already be there.
So I tried to do it on your network.
Yeah, I don't remember how. I have in my notes to do it on the graphing calculator, which tells me it probably doesn't work very well on the scientific. So
I kind of.
okay, on the back side, we're going to be talking about theoretical probability. A little bit of vocab first. The set of all possible outcomes to an experiment or activity is a sample space. So all the possible outcomes, definition there is sample space. When each outcome in a sample space has the same chance of occurring, the outcomes are equally likely. And this is theoretical probability. Okay? Theoretical probability, again, this is a probability you're used to. We're going to talk about rolling a die on the backside. Okay? Officially, when you roll a die, it is supposedly equally outcome that you can get any of the 1 through 6. So, theoretical probability is M over N, where N is your sample space, so that's your total possible options, and M is the outcome in question. So, on the first example back here, what is the theoretical probability of getting a 5 on one roll of a standard number cube? Now, when they say standard number cube, what are they saying? A die, a single die. What is my sample space on a die? What are my possible outcomes?
1 through 6.
I could get a 1, I could get a 2, a 3, a 4, a 5, a 6. So what is the probability then of rolling a 5? Okay. Probability of rolling a 5, there's 1 chance out of 6. And I think I missed one like this on homework because I entered 1/6 on the Math Excel. And they didn't want 1/6. They wanted this as a decimal. What is this as a decimal to? Let's go with 3 decimal places because they did that a lot on homework.
0.167.
Okay, 3 decimal places, 0.167. Okay. B. Getting a sum of 5 on one roll of 2 standard number cubes. So now what are we talking about? Rolling 2 dice? A set of dice? A pair of dice? Now, how many possibilities on one die? 6. How many possibilities on the other die? 6. When you roll them together, how many possibilities?
12.
Not 12.
36.
Remember our fundamental principle of counting yesterday? There are actually 6 times 6, or 36 total outcomes. Now, we're going to go through and write a chart out. And this would be a chart. I don't know if you had any pair of dice in homework or not, but it's a good chart to be familiar with. When we're rolling 2 dice, okay, we're going to be organized about this. If you get a 1 on the first die, what could you get on the second die?
1.
A 1. If you get a 1 on the first die, what else could you get on the second die? A 2. If you get a 1 on the first die, you could also get a 3. If you get a 1 on the first die, you could get a 4. You could get 1 and 5. And you could get 1 and 6. Okay, those are my possible outcomes. There are 6 options here if I get a 1 on the first die. You see where I'm going to go with this next? What if I get a 2 on the first die? What could I get on the second die? I could get 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. What if I get a 3 on the first die? What could I get on the second die? 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. What else could we get on that first die? A 4. You get a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, a 4 and a 5, a 4 and a 6. What else could I get on that first die? A 5. You could get a 5 on the first die, a 1 on the second. 5 on the first, 2 on the second. 5 and 3, 5 and 4, 5 and 5, 5 and 6. Yes? Emergency?
Yeah.
Sign out. We also could go 6 on the first die. 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. Okay, guys. This is our sample space for rolling 2 dice. Okay? So this is when you were rolling. I'm going to say, I probably shouldn't say set, pair. Okay, so this is our sample space for a pair of dice. I would hold on to this as we go through this chapter, because might you come across this again? You could, and I don't want to have to write this all down again. Now, what is question B asking us? They want to know, getting a sum of 5 on one roll of 2 standard number cubes. So, sum of 5. Which pairs give me a sum of 5? 1 and 4, 2 and 3, 3 and 2, 4 and 1. How many pairs is that? 4. And by the way, this is a probability of getting a sum of 5. There were 4 possibilities out of how many?
36.
All 36 I wrote out. My brain first says that 4 over 36 can reduce to 1 over what?
12?
Nope.
1/9.
1/9. As a decimal, this is 0.111. Okay. One last one in this section. Getting a sum that is an odd number on one roll. Getting a sum that is an odd number on one roll of two standard number cubes. So we want a probability of an odd sum. How many total options are there going to be? 36, yes? Now, 1 plus 1. Does that give me an odd sum? No, 1 plus 1 is 2. That's even. 1 plus 2? That's 3. That's odd. 1 plus 3? Even. 1 plus 4? Odd. 1 plus 5? Even. 1 plus 6? Odd. 2 plus 1? Odd. 2 plus 2? Even. 2 plus 3? Odd. What else is odd? 2 and 5. Are you catching a pattern here? It's going to be every other one, isn't it? 3 and 1 is even. So 3, 2, 3, 4, and 3, 6 are odd. 4, 1, 4, 3, 4, 5 are odd. You can stop here. Are you realizing what's going to happen? What's my percentage going to be here? Half of them, right? So 5, 2, 5, 4, 5, 6, 6, 1, 6, 3, 6, 5. So you could stop right there and say, okay, I don't even need to know how many out of 36. I realize it's going to be half of them, right? It is 18 out of 36. That does reduce to 1/2. This is 0.5 as a decimal. So sometimes you will be able to realize, oh, it's every other one. It's going to be half of it. Which, if you think about it, that makes sense, doesn't it? If we've got all these ordered pairs here. Okay. We are not doing, it's probability using combinations. I don't know, combinatorics? I don't even know how to say that word, but we're not doing probability using combinations. So we're skipping over that section. We're going to go to the bottom section because this is an important one to talk about. Sometimes you can use areas to find probability. And that's what we're going to look at here. So we have a picture drawn. A batter's strike zone depends on the height and stance of the batter. What is the geometric probability that a baseball thrown at random within the batter's strike zone will be a high inside strike? Okay, so we are trying to find the probability of a high inside strike. Now, realize, are you guys understanding what this picture means? I don't know how many of you know baseball, see it on TV. But on TV, they'll show a strike zone as a rectangle, yes?
Yes.
So this whole big rectangle represents the strike zone. So this batter's strike zone is, it's really blurry on here, 17 inches wide, 22 inches tall. Now, where is a high inside strike? It is in that little 6x4 area. Okay. Now, with that in mind, we want the probability of a high inside strike. I already mentioned that we're going to use what to figure this out? Area. Okay. So when you talk geometric probability, you use area. So on top, we're going to be doing the area of what? The area of the high inside zone. What am I going to be doing on bottom? Area of the total strike zone. Okay, so it's the area of that specified piece, small piece on top, divided by the entire area on bottom. Well, please tell me we know how to find area of a rectangle. What are we doing here? On top, how am I going to find area of that strike zone? Of the inside, the high inside strike zone. We're going to do 4 times 6, which is 24. What are we doing on bottom? Area of the total strike zone. What's the area of the total strike zone? What's the, I just know 17 times 22. 374. Now, technically that's going to reduce, but go for the decimal. What is this? 3 decimal places. 0. Point what?
0.64. Or 6.4.
Okay. 0.064. Now, did you notice all my decimals today start out 0 point? Your decimal answer should always start off 0 point. Okay, because we're not going to have those probabilities over 1. Just like Noah going back to earlier, the bigger number is always going to be on bottom. Generally speaking, yes. Okay, your homework, of course, is on Math Excel. Lesson 11.2 in Math Excel. One thing, guys, give me your attention for a moment. How do you find the area of a circle?
Radius times
Pi.
r.
R pi.
Isn't there like a 4 over
Pi r. Yeah.
I was on it, I just had it.
Okay, so I'm throwing this at you because I remember the geometric probability one I worked involved area of a circle. So you have to know area of circle being pi r squared.
And R pi squared. That's close.
Square on the wrong piece. But. Okay, guys, do the homework for tomorrow. Do tomorrow, right?
What's the probability?
Hey, I got it done.